Okay, we're talking about properties of logarithms. So, just to start and clarify, all of these properties are going to have these same restrictions on them, and that is that a has to be positive, a cannot equal 1, and that n has to be a real number. U and v are supposed to be positive real numbers, because you remember you can't take the log of any negative number. Okay, so I have a list of the log properties and then a list of natural log properties, and what you're going to see is that these are both basically the same property. It just sometimes people get confused when it's written in natural log format as opposed to a log base anything. So the first property we're going to talk about is if you were going to take the log of something that is a product of two or more numbers. So the log base a of, say, u times v. What you can do is you can break that up into the sum of two individual logs, one of the u and one of the v. So if these two things are multiplied, I actually can write it as two separate logs of u and v added together. Okay, now this looks like the same property. It is the same property. It just looks a little different with the natural log representation. Okay, so just remember, if you have a log of a product, rewrite that as the sum of logs. All right, so then if we go down here, we have the log of a fraction, so two things that are being divided. What you can do is you can break that up into two logs that are actually subtracted from one another. The number or the term that's on top of the fraction in the numerator, you're going to take the log of that first, and then you're going to subtract the log of the term that's in the denominator. Okay, it looks exactly the same. We're still subtracting here, natural log of u minus the natural log of v. And then the last one is the power property of logs, and this is if you have a log of a number that has its own exponent, what you get to do is you get to move this exponent in front of the log and then multiply it by the log base a of u. And then this one, same thing, the n is just going to move into the front. So you have n times the natural log of u. So you guys need to commit these properties to memory. You're going to be going from an expression that looks like a single log into the sum and difference and multiple of logs. And then you're going to have some problems where it's all going to be written out as sum and difference and multiples, and then you have to put it back as a single log. Okay, so let's practice. First one says, write as a sum, difference, and or multiple of logs. So we can see we have one log here, base 10, so we're not going to write base 10, of 5 times x cubed times y. So all of these are being multiplied together. So the first thing I can do is I can separate this into 3 different logs, one with 5, one with x cubed, and one with y. And since they're all multiplied together, I'm going to add the logs. The last little simplification I can do is since this log had x raised to a power, I can move that 3 in front. And I'm only moving it in front of this log because it's only the x that's being raised to the 3rd power. Okay, let's try it again. We have the natural log of, we have this big, huge quantity of the square root of 3x minus 5, all divided by 7. So the first thing I'm going to do is, since I recognize this as being a division, I am going to subtract these two logs, one with the numerator and one with the denominator. The next thing I'm going to do is, if you recall, the square root of something can be written as an exponent, right, for the rational exponent of 1/2. And so now I can use my power property and move this 1/2 in front of this natural log, and I would have my answer. Now, some people might look at this and think that they distribute to both of these, but you can't. This is one quantity, and we can only break it up if this would be multiplied or divided. Could we break it up into other logs? So do not distribute the 1/2 natural log to the 3x to the -5. We're done at that point. Okay, let's try going the other way. So what if they give you something where it's a sum or a difference or a product of logs, I'm sorry, multiple of logs, and you needed to write it as one single logarithm. So you'd have to recognize that since these are being added, I'm actually going to multiply y and z together. So I'm actually just taking the natural log of the product of y and z. Okay, let's try one a little bit more difficult. We have 3/2 times the log base 7 of z minus 2. So this right here, remember, if it's multiplied to the log, that's actually the exponent up here. So I'm going to write that first. But then what I want you guys to make sure you do is anytime you are writing as a single quantity of a log, I would like this rational exponent to be converted into radical form. So that means that this 2 that's in the denominator means that there's a square root around the z minus 2. And the 3 in the numerator means that this whole quantity is being cubed. So I actually would like you to write your answer in this format. Okay? One last example. This one kind of puts it all together here. We have 3 times the natural log of x plus 1/2 times the natural log of y minus 4 times the natural log of z. Now, when I go through and I look at these things, in my mind, I tell myself anything that is a positive log, anything that's being added or is a positive log to begin with, means that that is something that's going to be in the numerator and multiplied together. Anything that's being subtracted is going to go in the denominator, and if there's more than one thing being subtracted, all of those things that are subtracted are going to go into the denominator, but they're going to be multiplied together in the denominator. Does that make sense? Hopefully. Okay, let's try it. Okay, so the first thing I'm going to do is this 3 and this 1/2 and this 4, I'm going to move up to exponents. Okay, now that that's done, now I'm going to combine these. So this x cubed and this y to the 1/2, since these logs were added together, are going to actually be multiplied together in the numerator. And I went ahead and converted the 1/2 exponent into the square root of y. And then down here, this is a minus natural log of z to the 4th. So z to the 4th goes in the denominator since it was subtracted. Now, had I, for example, I'm going to write in here, say I said minus the natural log, ooh, writing pretty good, of, say, w. Okay, so say I actually had all of this. This w right here, since it's subtracted, would also go down here in the denominator, and it would be multiplied to the z to the 4th. I hope that makes sense. Okay, so that wasn't really part of the problem. I'll make that go away. Let's move on. Change of base. So we're going to go through and look at how to derive the change of base formula, and you will be responsible for knowing how to derive this formula on your test eventually. Okay, so the idea is that your calculator only has 2 types of log keys. It's the common log with base 10 or the natural log, which is a base e. So if we needed to evaluate a log that did not have one of those bases, but we needed to use a calculator for it, we're going to have to use a change of base formula. So let's go ahead and derive it. So first, to derive it, you're going to start off with a log, a basic log. Y equals log base a of x. Okay. Next, what you're going to do is you're going to take this log and convert it into exponential form. So here's our base, there's our exponent, it's going to equal x. The next thing we're going to do is we're going to do to one side that we do to the other side, and that is that we're going to take the log of both sides. But our log is going to be base b. And this is just in general, it could be any base that we want as long as it fits the restrictions. But we're going to do it to both sides so it keeps it balanced. Okay, and then what we're going to do is we're going to use our new property of log that says this exponent can now be moved to the front of that log. Okay, and remember we're trying to have a formula on how to evaluate this, so we want it to be y equals something. So y is being multiplied by this log, so I'm going to divide both sides by the log base b of a. And that right there, folks, is your change of base formula. So I'm going to put that on the new screen. Okay, so our change of base formula says that if you have a log base a of x, you want to evaluate it, take the log of base b of x, and then divide it by the log base b of a. And the thing is, hold on one second. There we go. I had to turn the lights back on. They went off on me. It's that late that I'm here at Lynbrook. use either base 10 or base b for these two logs, because you can use whatever base you want. Just make sure you're consistent. And then you would be able to use your calculator to evaluate, right? Okay, so memorize that and remember how to do the derivation. Let's put this into play here. So say we had to evaluate the log base 4 of 30. Well, I'm going to use the common log, and I'm going to say that the log of 30 divided by the log of 4 is going to get me the actual value of the log base 4 of 30. And the way you can remember it is that if you look at these two numbers, one is slightly on top of the other or above. The number that's above goes on the top, and the number on the bottom goes on the bottom. Okay? And so when you plug that into your calculator, this is what you get, and then you end up getting 2.453. And it does keep going on, I just rounded. Okay, when we do this example, I'm going to go ahead and use the natural log instead of the common log. It'll work the exact same way. I can say the natural log of 14 divided by the natural log of 2. Just don't cancel the 14 and 2, just like we didn't cancel or simplify 30 and 4. That doesn't work that way. And you get 3.807. And you can go ahead and test these. You know, you can try doing the change of base formula for this problem using the natural log, or you can try using the change of base formula using the common log over here, and you should get these same two answers. Okay, that's it for properties of logs and change of base formula, and you should have some fun working out these problems. Bye.